Well, we don't know because we don't understand it.
So you're saying it's doing unusual stuff, but you think it's just a comet?
Yeah, I mean, at this point, given all the data we have, I would agree that it's most likely natural, but there are still a lot of things we don't understand about it, and it didn't look like comets that we are familiar with. So let's try and figure them out in the coming months. And then, of course, it will get closest to Jupiter on March 16th. By the way, it had a rendezvous with two spacecraft that were human-made, JUICE and the Europa Clipper, and that happened just over the past month, and it will arrive in March 2026 to Jupiter, whereas these spacecraft will arrive in 2030 and 2031, just to show you how much faster it is, which means that I would love to actually hitchhike and go on a ride with this very fast interstellar visitor, because it will exit the solar system well before Voyager, that we launched in the 70s.
So you have a few more months when we can get some good images of this thing. You now say it is a comet, but you also point out it's done a lot of very unusual things. Does that raise the question, where did it come from? Is it made of a different kind of substance? I mean, what are the still unresolved questions in your mind?
The main unresolved question is, why does it have this jet pointed at the sun? That it also rotates with the rotation axis in the direction of the sun at large distances. That's also very unusual, and it came in the plane of the planets around the sun. Again, an unusual fact. I would suggest monitoring it as it comes close to Jupiter. It arrives just at the distance where Jupiter's gravity dominates over the sun's gravity. If we don't see it doing anything unusual, then I would conclude that it must be natural, but let's keep an eye on it.
After its recent close encounter with Earth, the interstellar object 3I Atlas has once again emitted a series of mysterious radio waves, sparking intense interest among scientists. The Allen Telescope Array observed a series of signals emanating from the object, sparking fresh interest in its mysterious nature. These radio emissions, detected over several hours of observation, were notably weak, with an upper limit for isotropic radiated power placed between 10 and 110 watts. Despite the absence of any definitive technosignatures, the signals raise intriguing questions about 3I Atlas, especially in light of its interstellar origin. Scientists continue to investigate the possible connection between these emissions and the object's non-gravitational acceleration, which has been linked to outgassing, suggesting that the signals may be part of a typical cometary process. Another observation was made by the Meerkat radio telescope in South Africa, captured after 3I Atlas's closest approach to the Sun. This finding reveals radio signals consistent with hydroxyl OH absorption features, a common characteristic in comets as they outgas water and other materials. While these signals could potentially indicate a natural cometary process, the unusual nature of 3I Atlas's interstellar origin has led some to wonder if there might be other, yet-to-be-understood explanations. The emissions have drawn significant attention, particularly given the object's extraterrestrial origin, and similar signals have been detected in other comets. However, the possibility remains that the phenomenon observed in 3I Atlas is not unique, but part of a broader pattern seen across different cometary bodies. The combination of these two independent observations raises more questions about the nature of the emissions and their potential connection to solar radiation interacting with volatile materials in the comet's environment. As scientists continue to piece together the mysteries of 3I Atlas, a new preprint has shed light on its size, offering further insights into the object's remarkable nature. Combining the latest data on the non-gravitational acceleration of 3I Atlas with information about its mass loss rate, researchers have arrived at an estimated diameter of approximately 1 kilometer for the nucleus. This new estimate closely matches the predictions made in an earlier paper by Avi Loeb, published in July 2025, reinforcing the accuracy of these earlier calculations. The new size estimate for 3I Atlas, placing its nucleus at around 1 kilometer in diameter, is significant, but as with many aspects of this interstellar object, it comes with several uncertainties that must be addressed. The non-gravitational acceleration used to derive this estimate has been subject to revision since November 2025, with NASA's JPL Horizons data being updated multiple times. The normalization of this acceleration depends heavily on the sky localization uncertainties tied to telescope images of 3I Atlas, as well as the models used to understand how acceleration changes with distance from the Sun. Given the complex nature of these measurements, the possibility of adjustments to the size estimate remains high, especially as new data from future observations are incorporated. Another source of uncertainty lies in the momentum imparted to the nucleus. The current model assumes that the ejection of gas particles at thermal speed is the primary contributor to the object's acceleration. However, an alternate explanation, discussed in Loeb's work with Eric Cato, suggests that the momentum could be dominated by the ejection of fragments of icy material rather than gas. This shift in the ejected material could have a significant impact on the mass loss rate and, consequently, on the object's acceleration. The interaction of this material with solar radiation may also differ from what is currently assumed, making the nucleus size estimate potentially subject to further revision. Adding to the complexity is the directionality and velocity of the jets observed on the surface of 3I Atlas. Currently, there are no direct spectroscopic measurements of the velocities of the material ejected from the nucleus, which makes it difficult to accurately model the momentum transfer.
3I Atlas recently passed closest to the Sun and will soon pass close to the Earth. But it may not be in one piece when it does. Professor Loeb says that based on his calculations, it looks like 3I Atlas has been losing an extreme amount of mass, which could mean it's exploded into a dozen smaller pieces. So, is it just another fascinating celestial phenomenon, or did the mothership just separate into a squadron of reconnaissance aircraft?
This gap in data leaves room for speculation about the exact nature of the jets and their contribution to the object's acceleration. However, scientists are hopeful that future observations, particularly those by the James Webb Space Telescope, may provide the necessary spectroscopic data to refine these estimates and better understand the jet velocities. These upcoming measurements could clarify the role of the jets in shaping 3I Atlas's trajectory and mass loss, further informing our understanding of the object. One particularly intriguing aspect of 3I Atlas's behavior is the anti-tail jet, which appears to be oriented in the direction of the Sun both before and after perihelion. Images from the Hubble Space Telescope taken in July 2025 and again in November 2025 show this consistent alignment of the anti-tail with the Sun, suggesting a significant interaction between the object's surface and solar radiation. The object's trajectory was deflected by only 16 degrees at perihelion, based on Loeb's calculations, meaning that the momentum imparted by the anti-tail jets before and after perihelion nearly cancel each other out. This is an interesting detail, as it indicates that the jet dynamics could play a more subtle role in the object's overall motion than initially expected. The directionality of the jets, coupled with the object's relatively small deflection by the Sun's gravity, introduces additional complexities into the analysis of its motion, and future studies may need to account for how the jets have evolved over the past several months. These uncertainties become even more intriguing when we consider the major anomalies surrounding 3I Atlas, which continue to defy conventional explanations and add layers of complexity to its already mysterious nature. One of the most striking aspects of 3I Atlas's behavior is its trajectory, which is opposite to the direction of motion of the planets in the solar system. Astonishingly, its trajectory aligns within 5 degrees with the ecliptic plane of the planets, a configuration with a probability of just 0.2%. This alignment is so precise that it raises the question, could this have been designed? Such a remarkable feature suggests that 3I Atlas may not be a mere cosmic wanderer, but something far more deliberate in its path. Adding to the enigma, 3I Atlas's arrival direction coincides closely with the location of the infamous WOW signal, coming within 9 degrees of its position.
2 weeks ago, I realized the arrival direction of 3I Atlas was within 9 degrees of the WOW signal that was detected in 1977, which was
an enigmatic, powerful radio signal that definitely came from outside of this Earth. We don't know from where. It was coming from a source that was approaching the sun. And the chance of it aligning with the arrival direction of 3I Atlas is 0.6%.
The connection to the WOW signal, which has been a subject of intrigue in the search for extraterrestrial intelligence, only amplifies the speculation that 3I Atlas might not just be a natural object, but potentially something intentional, a signal in itself or a precursor to one. Another anomaly observed both before and after the object's perihelion is the presence of a sunward jet or anti-tail, which is not merely an optical illusion as is often the case with familiar comets. This jet's behavior differs significantly from typical cometary jets and may indicate the presence of a technological signature. Unlike the usual cometary outgassing, this sunward jet could be indicative of engineered propulsion or another deliberate action, raising the possibility that 3I Atlas is not just a comet, but an artificial object designed with advanced technology. The timing of 3I Atlas's arrival further adds to its peculiar nature. The object's path was fine-tuned to bring it within tens of millions of kilometers from Mars, Venus, and Jupiter, while remaining unobservable from Earth at perihelion, the point at which it was closest to the Sun. The likelihood of this happening by random chance is an incredibly low 0.005%. Even more astonishing is the forecasted perigove distance of 3I Atlas during its encounter with Jupiter in March 2026, which is expected to be 53.6 million kilometers, almost identical to the Hill radius of Jupiter. This rare coincidence raises questions about the object's intentionality, with some speculating that 3I Atlas could be preparing to release technological devices, possibly artificial satellites around Jupiter, particularly in its Lagrange points, where orbital stability and minimal fuel requirements would make such a maneuver feasible. The physical characteristics of 3I Atlas also raise serious questions. The object's mass is several orders of magnitude larger than 1I Oumuamua and 2I Borisov, yet it is moving faster than both. Given the scarcity of rocky material in interstellar space, the likelihood of a rock of this mass traveling into the inner solar system once every decade is incredibly slim. This raises the possibility that 3I Atlas may have been targeted to enter the solar system, rather than being drawn in by random cosmic forces. Such precision suggests a deliberate path that could have been carefully planned. Further examination of 3I Atlas's gas plume reveals another peculiar feature. It contains far more nickel than iron, with a nickel to cyanide ratio that is orders of magnitude higher than anything seen in known comets. This unusual composition, with a likelihood of less than 1%, hints at the possibility that the materials on 3I Atlas could be industrial byproducts. It's a curious signature, one that could imply a technological origin, where the object's surface material may have been manufactured, perhaps as part of a broader engineering process rather than naturally occurring through cometary outgassing. Even more baffling is the nature of 3I Atlas's jets. The object exhibits jets both in the direction of the Sun and opposite to it, requiring an unreasonably large surface area to absorb enough sunlight to sublimate sufficient ice for these jets. This suggests that the object's jets might not be the result of typical cometary behavior, but could instead be fueled by technological thrusters designed to produce such a complex pattern of movement. If this is true, it would push 3I Atlas from being a mere comet to something much more sophisticated, perhaps even an engineered spacecraft. Finally, 3I Atlas exhibited non-gravitational acceleration near perihelion, something more commonly observed in comets, but the magnitude and timing of this acceleration could be indicative of artificial propulsion. If this acceleration wasn't simply caused by the sublimation of ice, it might suggest that 3I Atlas is using engine-driven systems, further supporting the theory that this object is not a natural visitor, but a crafted device sent on a specific mission. These anomalies present a series of perplexing questions that challenge our understanding of interstellar objects. 3I Atlas remains an enigma, with its mysterious radio emissions sparking debate. The uncertainties in its size and trajectory, the object's mass, timing, and unusual material composition hint at something more deliberate than a random interstellar visitor, suggesting the possibility of engineered systems or even a mission targeting specific locations in the solar system. With such a high concentration of improbable features, 3I Atlas forces us to ask, is it a natural comet, or is there something far more deliberate at play? The answers remain elusive, but the mystery is far from over.